Sir,
Hi.
sir,
Yes, I'm listening.
good morning, sir. How are you doing?
I'm fine. It seems as you are very far. Can you please increase your voice or close to the
Okay,
mic?
let me try to. Can you hear me now?
Yes, yes, clearly.
Okay, so I would like you to repeat the last example 3.1,
The last
if
example,
possible.
3.1.
Yeah, example 3.1 from the guide. Before you start with
Mm,
the one
k-
for the day, which is 3.6 and 3.7.
3.1 from the guide.
Yes.
Okay, can you please give me a chance to do it during tutorial session?
Okay, thank you.
Yeah, please, yes. Okay, now we can start. So far, I believe and I hope that you know how to calculate or how to estimate the population mean and the population total. Now, I'm going to show you how to select the sample size to estimate the population mean and the population total. Before we do that, let me just open the window journal for you. Okay, a bit while I'm still opening it. I hope you can be able to see it. Now, this is lecture number 7, where I'm going to introduce you how to select the sample size based on the population mean and population total. Okay, this lecture number 7, if I'm not mistaken. So it's about selecting the sample size. The sample size for estimating the population mean population means and totals. Okay, so how do you calculate the sample size required to estimate the population mean? Let's start with that one. Let's say the sample size required to estimate the population mean. So if you want to estimate the sample size, to calculate the sample size required to estimate the population mean, you have to use small n, which is equal to, this is the formula, n sigma squared divided by n minus 1, close brackets, times d plus sigma squared. So this is the formula that you can use to calculate the sample size required to estimate the population mean. So where d in this regard, where d is equal to b squared over 4. And then you know that the capital letter N, Stand for the population size, isn't it?
Sir,
Yes.
what's that potato-like symbol there?
Come again.
That potato-like symbol, is that how it's written?
Which one? Which one are you referring to?
The one where you say it's equal to b squared over 4. Is that how it's supposed to be written?
It's d equal to b squared over 4. D is this one.
Oh, it's d. Okay, sir.
Yeah, it's d. Sorry. That's d. This d is equal to b squared over 4, where a capital letter N represents the population size, as you know, and the sigma squared is the population variance, okay, and d is equal to b squared over 4, where b represents the what? The bound. So in other words, we just want to calculate the sample size required to estimate the population mean with a bound. Okay, so this is the formula that you use to estimate the what? To calculate the sample size. Okay. So now, if you want to calculate the sample size required to estimate the population total, so the sample size required to estimate the population total is tau. Okay, we use the same formula, exactly the same formula, n equal to capital letter N sigma squared over n minus 1. Let me just increase this. Sorry for that. This one too. Okay. N minus 1 is the same thing. Open close brackets times d plus sigma squared. The same thing, but the difference at d. Now d is equal to b squared over 4n squared. See the difference between the two formulas? The one for population mean and the one for population total. Formulas are the same, but the difference is at d. For the population mean, d equal to b squared over 4, and for population total, d is equal to b squared over 4n squared. So those are the two formulas that you can use to calculate the sample size required to estimate either population mean or population total. I think we are together. So now let's go to the example and apply this. How do you calculate that? Based on the example. So let's consider example 3.8 on page 17 of our lecture notes. Example 3.8. Okay, that's it. That's page 17. Lecture notes. Okay, page 17 in a lecture notes. May I give you some few minutes while you are trying to look at it before we start solving it? Page 17, example 3.8. It's talking about the average amount of money for hospitals, account receivable, And
Sir.
in this case, they're indicating that, okay,
Sir,
yes.
this one on red is the standard deviation or the variance? The one,
Which
the
one?
range.
No, the
100
standard
plus minus
deviation is
range.
the standard deviation is not given. They gave you a range, and then from a range you can find the standard deviation. I will show you how to do that.
Okay.
So now I wanted you just to analyze and see what is given, what is not given. How do you just find what is not given there? Okay. So I was saying that they are saying that there is no prior data available to estimate the population variance. You see now. However, they gave you a range. Okay. They know very well that from that range, you can be able to find what? The population variance. Okay. So I will show you how to do that. So you have been given the population size as well, which is 1,000. Open accounts there. They want us to find what? The sample size required to estimate the what? The population mean with a bound on the error of the estimation, which is P equal to $3. Okay, now let's start. Like I said, the population variance is not given. However, if the population variance is not given, but you have been given the what? Let me just write the given information here. They gave us a range, which is equal to $100. Okay, let's just forget about the dollar. Then they gave you the population size, N, which is equal to what? 1,000. Okay. And they gave you a bound, B, which is equal to $3. Let me just write it. And in this case, we don't have what? The variance. Okay. So let's start by how do we deduce the variance while we have been given the range there. So now, if you have not been given a range and you have not been given a variance, but you have been given a range, we know that a range R is always equal to 4 times standard deviation. That's the formula. If they gave you a range and they didn't give you the what? The population variance, you can deduce the population variance based on this given information here. R is equal to 4 SD. SD stands for the standard deviation. So which is equivalent to what? To 4 times what? A sigma, isn't it? Because the standard deviation is a sigma. Okay. So now we just want to find the variance. So you can square both sides, isn't it? R is equal to 4 sigma. So we are going to have R squared, which is equal to 16. Then there is your variance. But you want to find what? The variance. This implies that your variance will be equal to R squared over 60. Okay, R squared over 60. So now you have got your variance. Okay, so which is equivalent to what? R, the range is 100. Then you square it. Then you divide by a 16. What is the answer? So those who are using the calculators.
Sir,
Yes.
what happened to the D, sir?
To the what?
The D.
D.
And we have four times S
Oh,
times D.
it's R equal to 4 SD. S
Yeah.
is for standard, D for deviation. So in other words, it's supposed to be SD. Actually, I made a mistake to put the
Oh,
dot there.
standard deviation.
Yeah,
All
standard
right.
deviation.
Oh.
Let me write it nicely so that you can see. For SD. SD for standard deviation. So I'm waiting for the answer.
Is 625.
625. Yes, that is our variance now. So now we have our variance, so we can
Sorry,
use.
sir. Sorry?
Yes.
Yeah, I get initially R was equal to 100. So what happened? Because here I see R is equal to 4 standard deviation. Is the what happened actually? Can you explain to me?
Oh, actually, if they didn't give you the population variance, you know that the population variance is not there, it's not given. Okay. However, they gave you the range, which is this one. Now we know that from the range you can find the variance, and the way of doing this is to say R equal to 4 times standard deviation. Okay. This is the formula that you can use if you have been given the range, but they didn't give you the variance, isn't it? Our main idea here is to find the variance, but they gave us the range. So that is why we're having R equal to 4 times standard deviation. And the standard deviation is equal to sigma, isn't it? So that is why SG there, we substitute it by sigma.
Oh, okay.
Okay.
Oh,
Then
now I
from there we
understand.
square both sides. So now we are having all the information required. Now we can calculate the sample size. According to the example here, yes.
Come
again?
Page 1.
Go back. Okay.
A.
Yeah.
Yeah, thank you. Can I fit? Thank you.
Okay. Okay, thanks. So we want to calculate the sample size required to do what? To estimate what? Are we estimating the population mean or population total in this regard?
Come again, sir.
I'm asking here, are we going to calculate the sample size for estimating population mean or population total, according to that example?
Yeah, it's population mean.
Yeah, it's population mean. So the formula that we are going to have is N equal to N variance divided by N minus 1, okay, times D, and our D is what? It's B squared over 4 plus a variance, isn't it? And now our population size is what? It's 1000. Then multiply by variance, which is what? 625. Then you divide everything by what? N minus 1. It's 1000 minus 1, which is 999, isn't it? Okay. Then multiply by B squared. B is 3. B squared, you're going to have 9 over 4. Then you add what? The variance there, which is what? 625. Yes. Can somebody calculate it for us?
Yeah, so
Sir,
Mm.
it's 217,562.
217.5.
562.
sir,
Yes.
sir, since we are calculating the sample size, is it allowed? Commas are allowed.
I wanted to come to that point. You're in a hurry. You're in a hurry. So I will explain that. Let's write this one down, then I'll answer your question. So it's 217.5662.
562.
Okay. Now, because this one is a population size, it's supposed to be a what? A whole number, isn't it? So then you can convert to what? 218. All the sample sizes supposed to be a whole number. So it's 218. You answered?
Yes, sir, yes, sir, yes.
Okay. Okay, thank you very much. Now, I want you to do example 3.9 down there. Example 3.9. So this one was example 3.8. Let's go to example 3.9. Sorry. Example 3.9. I'm just giving you 3 minutes to do that.
So, which study guide are you using?
I'm not using a study guide, I'm using a lecture notes. Isn't that I gave you a study guide and a lecture notes? So I'm
Yes.
using a lecture note. Oh,
Because in the study guide, the example that we were just doing right now, it is 3.6, 3.6. Yeah, it is
no, don't
3.6.
consider the study. Don't consider the study guide because some of the exercises and examples are not there. It's incomplete. Just use the lecture notes, page 17, example 3.9.
All right, thank you.
Okay. Are you done?
Yeah, done, sir.
Okay. So let's do it together so that you can compare with your answer, isn't it? Okay, let's start with the given information so that it can be clear for us. You have been given the population size there. Capital letter N, which is equal to what? 1,000, isn't it? And you have been given a bound also. The bound is what? Can you tell me the bound?
It's
B,
1,000.
1,000 again. And then the last thing is what? Population variance is there.
Yes.
What is the population variance?
It's 36,00.
It's 36. Yeah. So they want us to find what? The sample size.
Yes.
To estimate what? Sample size required to estimate
Population total.
population total. So we're going to use n equal to n sigma squared divided by n minus 1. Our g now, because it's a population total, you're going to have b squared over 4n squared, isn't it? Then plus population variance. This is the formula that you're going to use, isn't it? So the population size is 1,000 and the variance 36. Then you divide by what? 999.
86 squared, you say?
Uh-uh.
It's fine. It's fine. Yeah, it's fine.
It can't be 36 squared. Yes. A bound is what? It's 1,000, isn't it? 1,000 squared. Okay. Then you divide by 4 times 1,000 squared. Then plus 36. Isn't it? We included everything, isn't it? Then can you tell me the answer is what?
Yes.
The answer is what?
125.98.
25.98, because it's a sample size, it has to be converted to 126. So that's it. That's our sample size required to estimate the population total. I think it's clear. Can we be able to do exercise 3.2? But anyway, this one you can do it on your own time. So let's quickly go to another topic, the estimation of the population proportion. Just please go and do exercise 3.2 on page 70 on your own time. For now, we just want to go to the population proportion. Okay, estimation. Estimation of population proportion. How do you estimate the population proportion? Now, so the population proportion is given by P. Okay, let me write it down. Population proportion is given by P, which is equal to the summation of y over n. And this one is equivalent to what? If you still recall, summation of y over n is equivalent to? You can tell me. It's equivalent to what? The population mean, isn't it? Which is?
Yes, the population mean.
Mu. This one is equivalent to the population mean. So, how do you estimate the population proportion? Sorry? How do you estimate the population proportion? Okay. Now, estimated population proportion is given by, now we are estimating the what? Population proportion by P hat, isn't it? Okay, which is equal to summation of y over sample size. Okay, and this one, because the population proportion, which is summation of y over n, is equivalent to the population mean, so the estimated population proportion will be equivalent to the estimated population mean, isn't it? Which is what? Mu hat, which is the same as y bar. Okay. Now, so what is the variance of the estimated population proportion? What is the variance? How do you calculate the variance of the estimated population proportion? Variance of the estimated
The population distribution of the
population proportion.
population.
So the variance of population proportion is given by var of P hat. This is the variance of the estimated population proportion. Var of P hat, which is equal to
Semangar follow me,
yeah.
Mike. Semangar follow me, Mike.
There is somebody who's making noise there.
It's
Thank
manga.
you very much. This is manga. You're making noise, please. So var of estimated population proportion, which is equivalent to what? To n minus n, all divided by n minus 1, multiplied by p q over n. So this is the formula that you can use if you want to calculate the variance of the estimated population proportion. Okay. Where in this case, capital letter N is for the sample size, small letter n is the sample size, and then Q estimate is equal to 1 minus P hat, isn't it? I think you are aware of this. Okay. So this is how you calculate the what? The variance of the estimated population mean. So now, how do you estimate the variance of the estimated population proportion? If you want to estimate the variance of the estimated population proportion, you have to use the var of P hat, okay, which is equal to n minus n divided by capital letter N, multiplied by Q, PQ divided by N minus 1. You see that? See the difference between the two? The first one is when you want to calculate the variance of the estimated population proportion. That's the first one. So use that formula. The second one, you use it if you want to calculate the estimated variance of the estimated population proportion. You use it when you want to estimate the variance of the estimated population proportion. I think it's clear there. So now, what is the bound now on the error of estimation for the estimated population proportion? So how do you find the bound on the error of the estimation for the estimated population proportion? So you have to use B equal to 2 times the square root of the var of P hat. Okay, so here we just want to calculate the bound on the error of estimation for the population proportion. Okay, so use this one, which is equal to what? 2 times the square root of, what is the var of P hat? The same as that formula up there, n minus n divided by n minus 1. Okay, multiplied by what? PQ hat divided by n. Okay, so this is the bound on the error of estimation for the population proportion. Okay, so now the bound on the error for the error of estimation for the estimated population proportion is going to be equal to, let me just take it down a bit. Sorry for that. The bound on the error for the estimated population proportion. Hey, what is happening here? Bound on the error for the estimated population proportion. Yeah.
Sir.
So this one above there is the bound on the error of the estimated. It's bound on the error of estimation for population proportion. This is the one. Now the bound on the error of the estimation for the estimated population proportion is going to be B equal to 2 times the square root of var estimate P hat. Let me repeat. The first one, this one, is the bound on the error of estimation for the population proportion. Number 2 is the bound on the error of estimation for the estimated population proportion. I think it's clear, which is equivalent to 2 times the square root of n minus n divided by n times PQ estimate over n minus 1. I think you can see the difference between the two.
Sir,
Any question? Yes.
I wanted to, as the class rep, like I wanted to ask for the breakdown for the students. At least maybe it can be 5 minutes or 10, so that they can digest this thing. Because
Definitely.
we are different. Some they need time to
No,
digest.
don't try to elaborate. I got and understand the message. Okay, let me
Yes.
just give you 10 minutes. Okay. We'll be
Alright,
back at 8:20 because now here is 1:15. Giving 10 minutes, we are going to be coming back at 8:25.
Alright, no problem.
Okay.
Sir,
Yes.
before we go for break, what
Yeah.
did you say the bound for the second one is for?
Oh, let me just repeat again. The first one, this one, is the bound on the error of estimation for the population proportion. Okay, that's the first one. The second one, this one, is the bound on the error of estimation for the estimated population proportion. Did you get the difference between the two?
Yes, sir. Thank you.
Okay, so see you after 10 minutes.
Say,
It breaks, manga. It's break.